Caffeine is a chemical that is primarily found inside of coffee, and coffee, and especially the caffeine part of coffee, is said to be really good for your productivity. It means that you don't feel tired as much. It just stops you feeling sleepy. It's a stimulant, and so it's going to make you feel more awake. But what exactly is the mechanism? How does caffeine go from being something in coffee to being something that makes you a little bit more hyperactive, a little bit more jumpy, and all round more productive, more able to sort of do things while not being tired and falling asleep and stuff? Now, I personally don't drink coffee, but I know a lot of people do, and so this video isn't necessarily like a verdict evaluation, should you, shouldn't you. It's also not like a how should you optimally drink your coffee, what kind of type of coffee to drink, what time of day to drink it. And I mean, I know one thing for sure is that drinking coffee immediately before you go to bed is going to mean that it's going to be a lot harder for you to fall asleep. So if I ever do drink anything that's got caffeine in it, but as long as it's 8 to 10 hours before I go to bed, then I'm sure it's going to be all right. And that's just some generic, one small little piece of advice I'd give to anyone that does drink coffee, just so that you're not going to decrease the amount of things like REM sleep, deep sleep, and all that sort of stuff that caffeine does when it's sort of inside your neurotransmitter systems, your synapses, and all that sort of stuff. Now, caffeine has a structure very, very, very similar to some nitrogenous bases, adenine and guanine. Caffeine looks pretty similar. It has the sort of 6-membered ring and it has the 5-membered ring that are joined to each other, just as adenine and guanine do. Caffeine has a couple of the double bonds that are inside the 6-membered ring taken away because it has a few more carbon-oxygen double bonds. And all the nitrogens on the molecules are in the exact same place as those for the nitrogenous bases. Now, the molecular formula for caffeine is CaH10N4O2. And while I don't exactly know the molecular formulas for the nitrogenous bases off the top of my head, I know that caffeine has a couple extra methyl groups that go off some of the nitrogens. It has an extra carbon-oxygen double bond to guanine, and it has the 2 extras to adenine because adenine doesn't have any carbon-oxygen double bonds either. And that's basically the similarities and differences. And when you think of a chemical such as adenosine, which is adenine, the base, connected to deoxyribose sugar, adenosine is one of many, many, many things that is responsible for the sort of sleep-wake cycle. Adenosine buildup is said to be something that makes you a lot more sleepy and a lot more tired. And when you consider that caffeine looks a lot similar to adenine, and the adenine part is the bit that fits into the adenosine receptor, then it's sort of, you might start to get like an idea in your head of why caffeine fitting into the adenosine receptor might make you more like wakeful. Now, the fact that caffeine binds to your adenosine receptor would seem to be counterproductive. You'd think that something binding to the receptor and all the chemical signals that are passed on from that receptor, you'd think that caffeine binding to it when you drink it would make you more tired. But the problem is that caffeine does not work in the exact same way as adenosine does. Adenosine can fit into many, many different receptors, but caffeine, I think it can fit into like the A1A and the A2A receptors. And what caffeine does is it literally just sits in the receptor and does nothing. It doesn't set it off in the exact same way as adenine does, because it fits in the structure, because it has a very, very sort of similar shape, but it doesn't exactly set it off in the perfect way that means that the chemical signals and chemical reactions can take place for signals to be passed down for your cell to essentially sort of wind down and become more sleepy and tired, because that's exactly what adenosine does. And when you have caffeine, and the caffeine is in your synaptic sort of clefts, and it's binding to your adenosine receptors, and adenosine just can't get into that receptor, so therefore it's not able to set it off, which means that you just don't get that like sort of tiredness in a way. But the adenosine does not stop building up. The adenosine does not stop being made. Caffeine doesn't interfere with that process whatsoever. It just binds to the receptor. Well, not really binds, but it just fits perfectly into the receptor, but just doesn't really do anything to it. But the adenosine is still being produced and is still being sort of made by all your different cellular processes. So when caffeine eventually wears off, when the molecules just aren't able to like bind to the receptor but still not be doing anything anymore, they denature or they just go off and they end up getting excreted by the body, then all the adenosine that's built up is then going to rush into all those receptors. Your cells are going to get super sleepy almost immediately, and that's how you sort of get the caffeine crash, and that's how reliances to caffeine can develop, because you're going to have some coffee, you're going to feel really stimulated, very productive, but then you're going to have the crash, so you just have more coffee because that from sort of trial and error or some kind of pattern recognition, that seemed to be the thing that solved the crashes that you may have been having previously from other things like sugar, or for instance. So like it kind of carries on a cycle. You develop dependencies, reliances on it, and stuff like that. And another little tip I can give you is when you drink coffee or anything with caffeine in it, caffeine is at its peak quantity inside of the nervous system at 2 hours after it's first been drunk. Now it's at its peak quantity in the bloodstream an hour afterwards, but in the central nervous system, which is the different sort of system inside of the body, it is 2 hours. So if you are gonna like have coffee and then start doing work immediately, you won't really feel the benefits until like 2 hours or so down the line. So that's just another thing that I can give you, which may mean that you can schedule when you personally have coffee and when you sort of do your deep works and all that sort of stuff. Now, the reason that caffeine doesn't set off the adenosine receptor in the same way that adenosine does is something to do with hydrogen bonds. Now, hydrogen bonds are formed when a hydrogen atom is bonded to an electronegative atom, either nitrogen, oxygen, or fluorine. And that means that this hydrogen, the sort of bonding pair inside of this bond is pulled a lot closer towards the element that isn't hydrogen, essentially. And so this hydrogen is kind of electron deprived. And so another sort of element, and then you need another electronegative atom, the nitrogen or the oxygen or the fluorine, on another different molecule. And this will form a hydrogen bond where the hydrogen, because it's so electron deprived, will try to sort of physically bond with the other molecule, but it won't like properly bond like in a covalent way. And this bond is 1/10 the strength of a covalent bond, and because covalent bonds are pretty strong, that is quite impressive. Now, the way that like nitrogenous bases actually bond to each other in a way is through hydrogen bonding, and I'm also very sure that that is the way that things like substrates will fit into enzyme active sites. And the same can be said for chemicals such as caffeine and adenosine to adenosine receptors. Now, the reason that caffeine may not be able to set it off and set this receptor off as well or just entirely as adenosine does is because it may lack a few electronegative atoms or hydrogens in certain positions. That means that it can't form bonds in places where adenosine would form bonds, which would be like the physical signal, because hydrogen bonds aren't chemical bonds, they're physical bonds. They affect physical properties, not chemical properties. So it won't physically sort of affect the receptor, which is a protein, enough to mean that the chemical signals get sort of passed down. So even though it fits into the receptor, there is a reason why it doesn't set off all the things that's going to mean your cell starts to wind down and become a bit more sleepy and tired. Now, despite this meaning that you feel a lot more alert and awake, caffeine being in the receptor instead of adenosine at certain times of day and stuff can lead to other indirect effects that may not like be things that you thought of. You can feel more productive, feel a bit more relaxed, that's great, but there will also be other things that caffeine does that are caused by its mechanism with the bind or the not binding, essentially. And these are probably things that are worth knowing about. Caffeine is a stimulant and it increases your heart rate. Now, when blood is being pumped sort of faster around the body because your heart is beating at more beats per second, it's going to be passing things like nutrients and oxygen all around your sort of body and all around your muscles at a quicker rate. So it's going to mean that you feel more, you're not just going to feel less tired, you're going to feel a lot more awake and alert because your body's constantly being pumped with all these chemicals, and they're good chemicals for one, so you're not going to feel like lethargic and down, but you're going to feel alert, awake and productive, and hence that is one of the reasons that caffeine gives some of these benefits as well, because the mechanisms of adenosine and what that does to the body is like one of the main things like surrounding this whole topic anyway. And one of the main things that adenosine does when adenosine binds the receptor is it stops the release of certain hormones and neurotransmitters such as adrenaline. Adrenaline is known for your fight or flight response. What adrenaline does is it diverts a lot of blood flow away from your parasympathetic nervous system, which is the sort of automated control of your breathing, your digestive system, the stuff that happens in your body but you don't really notice. It diverts some blood flow away from there, and it will divert it towards your muscles so that you can sort of either fight or run away, essentially. Now, adenosine not stops entirely, but slows down the release of adrenaline, because obviously adenosine isn't going to shut off all of the cells at exactly the same time. But because adenosine is not able to bind to the receptor, adrenaline is able to roam freely at times when it would actually, on a normal human that didn't have caffeine affecting it, adrenaline would be decreasing, but instead it's increasing because there is no adenosine buildup anymore, because caffeine is there, and that's gonna be the thing that causes your heart to pump faster, to pump nutrients around the body, even though there is no tangible danger. Adrenaline is just allowed to run through, which causes this sort of increased heart rate. While the increased heart rate can have benefits, caffeine is definitely something that should be considered to be something that's in moderation. And if you have any reliances on it, like for instance, maybe you're going on holiday, and even though you're not going to be doing any of your deep work tasks, you still feel like you need coffee, because if you don't, you're going to go through the day feeling like a lethargic slug. And that's just not something that anyone wants to feel, because caffeine may not be something that's available to you at every second when you need it. So not developing a reliance on it is probably quite an important thing for your quality of life. Your heart can develop an arrhythmic sort of beat, and it means it's going to be like ba-dum, 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 and then it's just not going to be sort of in time. Your natural sort of electric pulse maker, I think it's called, something like that, which dictates when your heart contracts and beats, and it does all those sort of movements, can sort of be affected by caffeine as well. And because it's like it's beating at such a fast rate, it's going to get tired, and then it's going to have the sort of I can't say the word properly, arrhythms, and it's just not going to beat properly in time with how it should if like there wasn't any caffeine, or it was just having an increased fight or flight rate for a short period of time. But obviously the caffeine lasts for I don't know how long exactly, maybe 3 to 4 hours before you then get that crash. So yeah, that's just something that I think you should know. It's important to learn about this kind of stuff like caffeine, which is such a fundamental thing that pretty much occurs in everyone's daily life. I just don't really drink coffee, not because of any particularly healthy reason or anything like that. I just don't really like the taste. And because I've grown up not drinking coffee, and I've not like forced myself to drink it to be more productive in that sense, I just don't need it, and I just don't need it, and it's not something that crosses my mind when I'm like, oh yeah, I'm going to be productive today, I'm going to get loads of work done, because I just feel like my brain is just working and I'm not tired in general anyway. But for some people in some situations, caffeine can be very useful, especially if their life situation requires them to mean that they're not getting an adequate amount of sleep, they're only like 5-6 hours and all that sort of stuff. But with that, I recommend subscribing, because I like this community of young tribal people who are willing to improve themselves. There's so much more than they already have, and good luck.